In manufacturing contexts, productivity is very commonly assessed using indicators of efficiency, which are expressed as output versus input. So, productivity will be measured as the ratio between production volume, expressed in a certain unit of measurement, and the level of use of a certain production factor. We could measure materials productivity, machinery productivity, workforce productivity. Machinery productivity could be measured with reference to a single machine, a group of machines, stages of the production process, such as production or assembly department, or even the entire production system. When we want to analyze machinery productivity, it is important to classify the various states in which the considered production resource could be over the time. If we take, for instance, a very common classification scheme in operations management, we could single out the following states of production resource. Closed. The plant could be closed, not working, for calendar-related reasons. Nighttime, weekends, holidays. Organizational causes. When the resource is not working due to strikes and other organizational causes. Managerial causes. Idle time due to lack of orders or lack of materials. Technological causes. Idle time due to maintenance and machine breakdowns. Tests. Times in which the resource is used for test productions and trials. Setup. Time for changeovers or adjustments. Scrap. When the machine is producing defective, non-compliant products. Good. Time of good, compliant production. Graphically, the various states could be represented as follows. Another very commonly adopted framework of time aggregation is the Overall Equipment Effectiveness, OEE. OEE is essentially the ratio of fully productive time, the green shaded areas in the graph, to the planned productive time, the whole shaded area. In practice, OEE is calculated as the product of its three contributing factors: availability times performance times quality. Availability considers the impacts of all events causing idle time and downtime losses, and is calculated as the ratio between operating time versus planned production time. The planned production time is obtained by subtracting losses due to organizational causes and tests from the opening calendar time. Operating time is the planned production time minus all time losses linked to managerial or technological issues and setups causing stoppages in production, including breakdowns, failures, changeovers, adjustments, and so on. Performance takes into account speed losses and minor stoppages. It is the ratio between the actual average production rate and the ideal production rate. It could be also computed as ideal cycle time over actual cycle time. The ideal production rate is the maximum rate at which the process could operate in optimal conditions. Correspondingly, the ideal cycle time is the minimum cycle time in optimal circumstances. It is sometimes called design cycle time, theoretical cycle time, or nameplate capacity. The actual production rate is the ratio of total production, expressed for instance in pieces or equivalent units, over operating time. Performance is usually kept at 100% to make sure that if an error is made in specifying the ideal cycle time or ideal production rate, the effect on OEE will be limited. As the performance formula could be expanded as total production divided by operating time divided by ideal production rate, we can also express performance as the ratio between net operating time and operating time. Net operating time is the time that would have taken to produce the actual total production if the plant would have always worked at the ideal production rate. Quality takes into account time losses due to products not meeting the quality standards, and it is calculated as the ratio of good pieces over the total count of produced pieces. It could also be expressed as the ratio of fully productive time over net operating time. Fully productive time is the time that would have been required to produce only the compliant production, working at the ideal production rate. The OEE could then be rewritten as operating time over planned production time times net operating time over operating time times fully productive time over net operating time. As a result, the OEE is the ratio of fully productive time over planned production time, and it includes all losses due to managerial and technical reasons, speed losses, as well as quality losses.